Hi everyone, and welcome to my talk on drones, AI and IoT. I'm Adam Stephensen, I'm an app dev specialist who works for Microsoft, and I'm here to talk to you today about my experiences and what I've been working on for the last couple of months. Just so I can get an idea of who's in the audience, who's actually a software developer? Okay, fair few. Who's actually a data scientist? Got two data scientists. Excellent. We're going to talk more about you than to you, but you're a key part of this equation. Who's built or shipped an IoT solution? A couple. That's great. And who's worked on drones? One. Okay, this is awesome. So no one here has done AI on drones yet. Excellent. This is the perfect room for this talk. A few things about me. I love trying new things. I'm always interested in the new technology that comes out. I'm really proud that I worked on .NET Core when it was ASP.NET 5. I shipped 2 apps to production when it was .NET Beta, .NET Core Beta, and Angular 2 Alpha. I was back in using Azure back when it was possible to know all of Azure because it was 3 services. And this is my other new thing that I love playing with. This is my 6.5 metre surf ski. You might have picked it up, but I'm from Australia, and this is from Tallabudgera Creek, which is just down the road from me. So it's a beautiful part of the world, and we get to do some nice things. But like with all new things, there's often a learning curve and a few hazards. And this is going to come up a fair bit today. So the thing I want to talk to you about today is my learning curve around AI, drones, and IoT. And this actual moment is actually what spurred me to get into drones, and I'll talk about that a little bit more in a little bit. So AI is everywhere. So working for Microsoft, my job is to work with government departments and enterprises, helping them move their workloads into the cloud. So these are not traditionally agile, forward-thinking organisations. But I'm spending at least 50% of my time working on AI. 25% of my time is on building bots. I've actually got bot fatigue. I've built bots for medical, transportation, productivity. I haven't actually built a hospitality bot, but lots and lots of customer service bots and so many IT help desk bots. So organisations are saving thousands of man hours and massive amounts of money working in the bot space. Microsoft also has a massive investment in cognitive services. And now the nice thing about cognitive services is that it's a nice, friendly, RESTful API that lets us do amazing artificial intelligence things. So before cognitive services, we relied on having data scientists. And it's great that there's 2 in the room because they definitely deserve a lot of thanks. At one point I thought about going into machine learning, and I got told, all you've got to know is to know the right algorithm, and it's pretty easy from there. I looked into it, and that is a massive lie. To become a data scientist is a massive investment in time. It's a whole nother speciality. So it's great that we've got all of these nice, very easy to access artificial intelligence capabilities. The ones in black are actually the ones that I've used on projects just recently. So there's the facial recognition and identification APIs. We're able to take a photo, post it, and get information back. We've got emotion recognition, where we can take any text and get sentiment analysis back. How happy or sad is the text in that? Text writing and handwriting OCR. If anyone's interested, there's a really interesting case study that you can deploy to your own Azure subscription in about 20 minutes. And what it does is that we've taken the JFK files, which is typed text with handwriting over it and a whole lot of images, and we've actually taken it through and we've run using cognitive services, run our artificial intelligence over it and made it fully searchable. And not only that, it's taken all of the entities and made all the entities linkable. There's a whole lot of speech services, including real-time translation. The common scenario that we're doing there is for call centres in banks and government departments with 2-track audio. We're able to take both of those conversations and transcribe them into text in real time, extract out keywords, and then run sentiment analysis over it. So they're able to do really interesting things with that data. So for example, work out what keywords make customers or staff members unhappy, and then what are the follow-on actions from that as far as things like retention go. What I thought I might do is actually just jump across and show you what a few of these look like. So you can actually just come into the cognitive services pages, and there's amazing demonstrations here. So we can just come through and we can see how easy it is. Oh. Let's try that way. Okay, so we can come through and we can choose different images, and it'll analyze what's in those images and then return us nice JSON around those images. So where it gets really interesting, so here's an example of the cognitive service where we can pass in an image that has a whole lot of text in it, and it returns JSON that describes that. I did a proof of concept that took me one day. I had a massive engineering company. They had thousands and thousands of architectural drawings. On all of those architectural drawings, somewhere on there, there's a block that has the engineer's name, the date that it was done, and a whole lot of metadata. They were done, over a whole lot of many years. We're able to, in one day, build a cognitive service proof of concept that went through and extracted that typed and written information to tag it as metadata to make all of those architectural drawings searchable. So it's amazing the solutions you can deliver very, very quickly. My favourite of the cognitive services is the facial cognitive service. So we can come in here, take any image, post it, and it'll give us a whole lot of the information about the people in that image. So you can see here I posted up a picture of me. I come in, it says my hair is 97% grey, thanks Azure. So it does things like tells you about the facial hair, whether I'm wearing glasses, and some really interesting emotion detection. So it runs through, analyses the emotion in the faces, and then breaks it down. So in this one, I've got a 97% neutral face. If I was to go and put another image in there, you'd see that it's reanalyzing all of those things. And this is a RESTful interface that you can call from any programming language. I'm posting that image with a key, and it's giving me back that nice JSON data. So you can use this in any application. Pretty easy? Who can see some uses for this that they might like to put into their applications? Yeah, it's pretty awesome. Okay, I'm back up. Oops. Okay. A lot of people don't trust these artificial intelligence advances, and I think Siri burnt a lot of us. For many years, I kept trying voice to text. I kept trying intelligent agents, and the AI just wasn't there. We've really cracked that nut now. So in 2016, our object recognition in the cognitive services now reaches human parity. With our speech recognition, the standard for it is if you have two human dictators, not dictators, who are people who take dictation. If you have two people in a room taking dictation, listening to an audio stream, their accuracy is 95.1% accuracy. We cracked that in 2017. Our machine reading has reached human parity, as has our machine translation. So these services are getting better and better, and we're investing billions and billions of dollars each year in them. So they're things that you can easily leverage in your applications today. We still need data scientists, because there are much harder problems and there are custom problems that need to be solved. I work with a data scientist called Stephen van Bodegraven. And he's just finished a really quite amazing project. So I'm from Australia, and as you know, we like to talk about our animals, and we've got some very friendly, cuddly ones, and then we've got some that aren't. So Steve worked on a great project in the Northern Territory in the north of Australia. So in Darwin Harbour, it's a massive volume of water that's 5 times the size of Sydney Harbour. It's got more coral in it than the Great Barrier Reef, and there's a number of endangered fish species, including a number of endangered shark species. And what they wanted to do is they wanted to be able to monitor the fish health and monitor the harbour health, but they're having all sorts of drama with that. What do you think the drama was? Who wants to have a guess? The fish are underwater is one thing. Well, there's 4 species of aggressive sharks in Darwin Harbour. But in Darwin, they don't care about the sharks. Because if you were in the water with the shark doesn't actually want to eat you, and you've got a reasonable chance it'll swim past. What they do have, though, is saltwater crocs. And if you're in the water with a saltwater crocodile, it will eat you. Like, it's not it will always go for you, and you will always die. That's just the law. So what Steve did is he worked with the government department up there, and what they built was this machine learning model. So they built this model, and what it's actually doing is it's able to identify the 15 types of fish that they actually need to track underwater. So they put an underwater camera down in different spots in the harbour. It's baited so it attracts the fish in the area. And what they used to have to do was they would, put these cameras down, they'd record hundreds of hours of video, then someone would have to go through and try and tag it. Where now the full process is automated. So not only is it saving them man hours, they're getting much better data because they're able to collect much more data and it's able to process it for them. And using the full machine learning tools, it's processing it for them. This is not something that we could do with cognitive services. This is where you go, I'm building an application and I need my friendly data scientist to come along and build me a complex machine learning model. In true Microsoft fashion these days, of course, Steve actually went and took the instant segmentation pipeline. I don't know what that means, but this is the tooling that he wrote to actually perform that, to create that model, and it's out there on GitHub if the data scientists in the room are interested in going and checking it out. So what I just wanted to start with, before I get down into the IoT and the drone applications, is all of this is really built on a foundation of artificial intelligence. And at Microsoft, we've really got those, we get in there with those 3 different levels. We do lots of bots, we've got our cognitive services for our developers, and then we've got a large suite of machine learning tools that are available for our data scientists. We have a number of infrastructure offerings, and we're obviously, we've always been about empowering developers and creating great tools. So there's a whole lot of tooling options as well. So that's just day to day. And I've been doing lots and lots and lots of artificial intelligence. But then, I thought IoT was like blockchain. I thought, that's something maybe one day we'll start getting some traction. It was about 18 months ago that all of a sudden I started having government, once again, these same large government departments, large behemoths of companies coming to me and saying, I want to do an IoT project. We've got this use case and this use case and this use case. There's so many different organisations and government departments that are doing cool things. I've got a city council and it's using cognitive services for listening to the sound of mosquitoes swarming so that it's able to then release pesticide at the right time. Okay, there's all sorts of transportation, whether it's putting it on trains or large machinery, putting devices on machines to monitor their health. If you have a look at that slide, there's a pop quiz and a couple more slides and there's a clue on there. So there's lots and lots of really interesting IoT use cases around. And what IoT is really about is connecting things to get insights that can be quickly turned into action. So we've got a whole lot of things. Sometimes we've got tens of thousands of things. They need to be monitored. There's all sorts of things going on them. So we want to be gathering data from all of those things. So we're taking things, we're gathering data, we're turning data into insights, quite often leveraging some kind of machine learning. And from that, we want to be driving actions. And that's really the IoT process. Here's my quiz. What is this? What's on the cow? It's a Fitbit. It is. This is what Fitbits for cows look like. This is an old one. This one is just a pedometer. This just tracks steps. The new one actually tracks body temperature as well and has a voice recorder in it. So this is a really cool use case. So with dairy cows, and so this is from Australia but being used all over the world now. With dairy cows to produce milk, they have to go through a cycle of getting pregnant and giving birth. But there's only a very small window for them to be inseminated. Okay, so back in the olden days, the farmer spent a whole lot of time with the cows. He would literally spend hours and hours during the day, so he would know what cows were ready and what cows were fertile. Were they chewing? How were they eating? But with the pressures of today, farms are getting bigger and bigger. Farmers are not able to spend the same amount of time with the cows. So now we have, farmers needed new solutions. So that's why we've now got Fitbits for cows. This is the IOC reference architecture. Oh, is that a typo? No. What does IOC stand for? It's not inversion of control. Internet of Cow, that's right. So, what happens in our IOC architecture is we've got these cows with smart Fitbits. And what they're doing is they're tracking. When the cows are fertile, there's a number of signs. So they move around more, so we're tracking their movement, we're tracking their listening, so the audio is listening for them chewing their cud, because then we're watching how much they're eating, and there's a temperature sensor on the new one as well. So these are all going up into antennas that are then being transmitted either through 3G or through Wi-Fi out to the internet. Once it gets out into Azure, we're gathering all of that information around all of those cows, and we're then able to alert the farmer. This cow is ready to go. This cow isn't eating very well. So the farmer's actually now not having to worry about the monitoring, he's able to just take action. Pretty cool? It's very animal focused, this talk. When we start to talk more about the IoT reference architecture, this is something more likely that you'd find on the Microsoft site. And this is very typical. So what we've got is, we've got our IoT devices. You might have 2 or 3 IoT devices. Most of the scenarios I'm working in are from hundreds to tens of thousands of devices. So we've got tens of thousands of devices, and they're all spewing data into a cloud gateway. In Azure, we generally use Azure IoT Hub. It provides a whole variety of functionality. The most important ones that it does is around device management. If you've got 2,500 sensors, you don't want to have to be going and putting a connection string in each one. And every time there's an update, you don't want to be having to go and actually find those devices and update them. And Azure IoT Hub does all of that device provisioning and maintenance for us. So we've got IoT devices, they're streaming data up into our Azure IoT Hub. We're then able to push them into a stream processor, so something like Azure Stream Analytics, so we're watching the data as it's streaming through, and we're able to then, as it's streaming, detect alerts, and then call off to something, a business integration process, whether it's a logic app or a function or a bit of code, and able to actually take some action. This is a very common path, and then that might feed around through to UI. At the same time, we've got our cloud gateway also pushing our stream of data into a data store. Usually, this is one of my tips, is make sure you separate your data. So usually something like Cosmos DB for your hot storage, maybe some blob storage for your cold storage. This is a very typical IoT reference architecture, and this isn't hard to build. There's heaps of samples, heaps of demos to walk through all of this. So, as I said, IoT is all about things, generating insights, and then creating actions based on those insights. That IoT reference architecture part of it is actually the easy part of the equation. But there's so many challenges, and this was my experience with IoT and drones. The beginning bit's easy. The bit in Azure is easy, but then you start finding a whole lot of different challenges. How do I do security? How do I manage high availability? What about the device life cycle? There's so many different pieces. The network is a big challenge with any IoT solution. One of the projects I've done was putting 2,500 sensors through temperature sensors through North Queensland. So now you've got all of these devices and they're sitting out in the middle of nowhere. There's no network there. How are they going to communicate back? I'm going to put some sensors on a truck, and that truck's going to drive all around the country. And I've got lots and lots of sensors. There's a lot of the time where that truck's not available. How do I manage that process? How do I manage that stream of data from the truck up into the cloud? we've got a great answer for that, but I'll pivot back to that one in a little bit. Another one of the big challenges is around protocols. If you're building a cloud-native solution, if you're happily greenfield, there's really nice solutions that can work there. A lot of our IoT projects, they were going into brownfield devices where they're using legacy protocols, and you need to transform them to get them up into the cloud. So Microsoft's deeply invested in the OpsCUA project, so it's worth having a look at that. Or looking at Azure IoT Edge, which is what I'll come to next. Cost is a big driving factor. So this is one of the big challenges is around cost. And this is a general theme with IoT, is the cloud, and with drones, the Azure part's easy. We can architect code, we can deploy solutions. That temperature sensor scenario I worked with, they had their Raspberry Pi, they had their temperature sensor, then they went and built the whole cloud solution, and they're like, this is fantastic. And all I need is this Raspberry Pi and this temperature sensor. Then they went and got a quote to get the actual device built. How much do you think the temperature sensor cost? Does anyone want to guess? Anyone? No. You guys are so not in the bulk. $300 for a temperature sensor. How does that make any sense? They fell over. They were like, you have got to be kidding. And this wasn't through us, this is through someone else. But now when they actually thought about it, it makes sense. A temperature sensor on this IoT network in North Queensland in 46-degree heat for measuring ambient air temperature, it actually has to be held 1.2 metres off the ground. It's actually held in a special ceramic pine cone tree-shaped enclosure so that even in direct sunlight, it's actually not being affected by that direct sunlight. It also needed a battery that could last multiple months. So they'd gone and built this whole great solution. All they needed to do was organise the devices, and then they went back to the boss and said, actually, we need about $800,000 for the devices. So these things fall over quick. The challenge around that is getting into, speaking to someone who's actually done a lot of IoT early, particularly around the devices, because there's a lot of things you can do to actually plan this out. And to get around this. Device provisioning and management is complicated, and that's why we've got that Azure IoT Hub service, so that simplifies and takes all of the pain out of that one. HANDR for your IoT solutions is complex if you're not using a PaaS solution. If you're using a PaaS solution, you get all of that out of the box. Security, privacy, and trust is the other big challenge. Who's heard about the kids' toys that were hacked and everyone was spying on them? That is almost the standard. That story is so old, and I'll pivot back to that one in a little bit as well. So my top IoT tip, this is the number one mistake. People ask me, what's the number one mistake people see with IoT? Is don't just go with what you already know. I see everyone going and building IoT, and they're saving everything into SQL Server. So your data store selection is really important. So don't use a relational database for everything. Who's using something that's not a relational database already? Only a few. I have SQL 2008 R2 tattooed on my chest. Like, it was the best. It was the version of SQL Server that did everything I ever wanted. It was awesome. But if you're going to build cloud-based solutions, you need to look beyond. I'm a massive fan of Cosmos DB. It does so many things well for me, but no matter what your choice is, you need to move beyond your relational database and choose something that's more appropriate. You need to have polyglot persistence. Usually my hot store's in Cosmos, my cold store's in something like blob storage, depending on the type of data. We're regularly with IoT dealing with JSON data. It just makes sense. Prefer availability over strong consistency, and consider the skill sets of your developers. Cosmos is great, but if you're already invested in something else, run with that one. So as with our AI offerings, we have a number of IoT solutions. If you just want the easiest possible IoT solution, we have IoT Central, which is a SaaS solution. It's like Office 365. It's, you sign up, we provision it for you, we manage it for you, we scale it for you. You can't customize it though. Okay, if you want something off the shelf where you can just spin it up and you can go and buy a whole lot of devices and register them and that will be managed, IoT Central is awesome. Most of the use cases I'm seeing though using our PaaS solutions. Now, so this is using things like IoT Hub. If you go and have a look on our Azure IoT website though, you'll see we've got a whole lot of solution accelerators. So what these are is open source projects where you can say, go and spin me up a remote monitoring solution, and it will provision that inside your Azure subscription, and then you can customize it to your heart's content. So that's the easiest way to get into getting into IoT. Once you're there, then you can customize it as much as you would like. Now, this isn't the answer to lots of my previous questions. Everyone's familiar with cloud. We've briefly discussed IoT and AI. Where it gets interesting, and this is where I started to really invest in IoT, is when we start talking about the intelligent edge. So the idea of the intelligent edge is that instead of all of our devices having to talk straight to the cloud, we're going to go and put a device on the edge of the cloud. We're going to put it on the edge of our network, and all of our devices are going to talk to that edge device, and that edge device is now responsible to talking to the cloud. That's going to solve us a lot of problems and give us a lot of power. It looks like this. So we might have if we consider our cow scenario from earlier, or a really common scenario for this is on a farm. So agriculture is a massive IoT implementation, and you might have temperature sensors or moisture sensors distributed all over thousands and thousands of acres. You don't need every single one of those sensors streaming all of their data straight into the cloud. So what we do is we provision an IoT edge device, and all of those sensors are then talking back to the IoT edge device. What we can do then up in the cloud is we can actually leverage a whole lot of the other Azure services, things like Azure Machine Learning, the cognitive services, Event Grid functions, Stream Analytics or SQL Server. We can go and build applications, put them in Docker containers, because that's how we ship everything these days, move those containers into our container registry. Now, all we've got to do to get that functionality out on our edge is write a little deployment manifest. I push that deployment manifest using Azure IoT Hub out to the edge device. And what I can have now is I can have all of that smarts that I built in Azure running on my edge device. So what does that mean? That means I can be taking a really great machine learning model that our data scientist is running, I can containerize it, stick it in Azure Container Registry, and now I can be running it on my farm. Okay, now I don't need to be streaming the data from thousands and thousands of sensors all the way to the cloud when I'm out past Bilio. I don't know if you have Bilio here, but I don't know what the Portuguese equivalent to Bilio is. But out in the middle of nowhere, you may not have a great big internet connection. So what we're able to do now is run machine learning models close to our network and be able to have that decision-making process close and only need to emit our events out to the cloud. So that's going to save a number of those problems that we had earlier. In particular, it solves the network problem. It also solves the protocol problem, because now all of my legacy devices that I have are now able to communicate on-premise. I'm able to make that connection on-premise and then use cloud-native protocols to talk back to the cloud. So Azure IoT Edge is really, really powerful and really, really useful in your IoT scenarios. So the great things about Edge is it gives you that low latency and type control. It lets you pre-process the data on-prem, so you're not sending everything up to the cloud. Intelligence on the edge. It lets you do the offline operations. So in the scenario where I said there's trucks driving around the country, instead of having those sensors trying to stream, you can have those sensors talking to a small device on the truck that's caching that data and only is pushing back to the cloud when it comes back into range. I already talked about the protocol translation, and it also lets you protect data and privacy of your on-prem. So it lets you, anonymize data, for example. Now, I couldn't bring a drone. They wouldn't let me fly a drone here. Usually when I do this talk, I bring along a couple of drones. They wouldn't let me bring a drone, but I did bring a couple of things for show and tell. Everyone's seen a Raspberry Pi. Has everyone seen a Raspberry Pi? If you don't, you should go out and get one. These are super awesome. It is a little mini Linux computer. And we can run IoT Edge on a Raspberry Pi. And this is a really common demo. You can actually, and the steps for this are actually on the Azure website. So you can take this little Raspberry Pi, you can build a machine learning model in the cloud, you containerize it, it pushes it out to an Azure Container Registry. You can then take that machine learning model and put it down on the Raspberry Pi, connect a camera to the Raspberry Pi, disconnected from the internet, and you can then walk around, and if it's face detection, you can recognize people. If it's object detection, you can actually have it recognizing objects. And that's massively useful. So one of the scenarios that we're looking at using this in for Australia, I don't know what you might be more advanced here in Europe, but in Australia when we go to the checkout, everything with a barcode you can scan, but fruit and vegetables you've got to sit and use a silly screen. What I should be able to do is just drop my fruit on the scale, and a camera should be able to go, that's 5 apples. So once again, my friend built this scenario using this demo in about 3 hours. So you can solve real-world problems with this tech very easily. If you just go onto the Azure website and look for custom vision with Azure IoT Edge on a Raspberry Pi, it actually just steps you through all of the steps to do that. Super easy. That's pretty cool, but a lot of people say Raspberry Pi is a full computer. It's not really IoT. That's a bit big for IoT. So when IoT, we're often talking about MCUs. MCUs are harder to work with. So what Microsoft's released is this Azure MxChip. And the MxChip is an MCU with all of the sensors that not all of the sensors, most of the sensors you would need for most IoT projects. So there's motion sensors, infrared sensors, magnetometers, atmospheric pressure, temperature, humidity. There's a screen on it, there's multiple buttons on it, and you can even plug it in to get extensions. So we've built lots and lots of proof of concepts. We built a proof of concept for a nursing home that wanted to be able to detect using our AI when somebody fell over. So that was a trivial exercise to actually use the gyroscope on this to detect that. So if you go to the Azure website, you can order these. Then to actually program against them, they're in Arduino, you use Arduino, you jump into Visual Studio Code, add the Arduino extension, and then go to the website and follow through. There's a whole lot of different walkthroughs that'll take you the whole way through programming an MCU on the MxChip. What's really nice about this is this ties in with those solution accelerators. You can go in, deploy the solution accelerator for remote monitoring to Azure, which gives you that whole cloud solution. And then you can come in, get the MxChip, and go and do the remote monitoring project on the MxChip, hook them up, and you've essentially put yourself together a whole IoT solution. So I'm trying to make it as easy as possible for people to get into this. And Azure Sphere is the answer to the other of my unsolved problems on my challenges list. So when it comes to security on IoT, this is going to be a really hot topic. So what we've released is Azure Sphere. So Azure Sphere has multiple parts, but basically it's an end-to-end security solution for IoT. So it's actually a chip that has the security baked in with an operating system that runs on it that then connects securely to the cloud. And so this is when device manufacturers come in, they're using these MCUs to create secure IoT solutions. So that's also something worth having a look at. Now, this is my favourite thing and my worst thing from the last 12 months. When you do the Raspberry Pi solution, you can run AI on a Raspberry Pi. So when I said you can deploy that object detection container down that's going to run that algorithm, it'll take about 2 seconds when you point it at something for it to recognise it, because it's got an underpowered CPU on it. This is my Jetson TX2. This is the developer board for it. This is the de facto standard for running IoT on the edge. So as well as having a CPU, this has 256 GPU cores on it. This is made for running IoT. And it's as big, see I'm holding the heatsink, you can have a look at it afterwards. The board itself is the same size as the heatsink. This thing is tiny. So this is where we run, this is what we use to run our AI on drones. So we can build our models, deploy it onto this, and that'll run on a drone, running our AI on a drone. So we'll come back to him in a moment. So this is amazing. This is the next level of hardware if you're looking at running AI. And that's it mounted on a M210, DJI M210. You can see it sitting on the top there and it's mounted inside that little case. So look, on summary, if we're summarising IoT, Azure Sphere is great for end-to-end security, the MxChip is great for rapid prototyping, your Raspberry Pi is lightweight edge compute, and the TX2 is really what you want if you're going to be running AI on the edge. I love this story. This is actually a Norwegian, this is the story of a Norwegian, so all the rest is things we're doing in Australia. This is the story of a Norwegian company that's now doing work with Microsoft all around the world. And I am just going to flip over, let's see, it's going to work better this time. Oh. And I'm just going to play. Okay, so, oh, didn't work. So this is the story of a Norwegian company that does power line inspections. So what used to happen with power line inspections is that they'd have helicopters, and those helicopters would have to fly really close to the power lines to actually try and find faults. So they'd have, it's very risky, it's very expensive to fly helicopters, and it's really dangerous. It was costing lots of money. It's also highly inaccurate to have someone hanging out the edge of a helicopter trying to see whether a particular part on one of these massive power lines is faulty. So what happened is this company called eSmart Systems came along and they built a machine learning model for inspecting power lines. So you can see here what they're doing is they're doing object detection where all of the purple boxes are detecting disks and the red boxes are detecting the top of power poles. So they built this machine learning model and then they were able to put it on drones and they fly the drones around, and this is a map of their electrical grid, and the blue bit at the top is the 6 kilometres that they've just flown. So instead of doing that with helicopters, they're flying drones over that section of power line. You can see here, if we click on that and drill into it a little bit more, there's 217 objects that has been detected as they've flown that stretch of power line. Inside that 217 objects, there's 6 observations, and observations are what they call potential faults. So that's pretty amazing. And instead of having someone hanging out of a helicopter writing down where they thought that mistake or where that fault might be, it's all being tracked and logged using the drone and GPS. So they're able to drill into that. There's a number of challenges with this model though, and this is the same problem I'm facing on a number of projects, is there's the challenge when we come to AI and drones of small object recognition. So when we're doing object detection, you often need a low quality image. So what they had to do is they had to take that whole image of the power line, make it low quality, feed it into object detection, and that's going to pass them back those boxes going, here's the tops of the pole and here's where those disks are. Once they've got that, they need to take the high quality images inside those boxes and then run that through object classification to see, is there a fault or is there not a fault? So this has actually become a very common pattern that I'm seeing in drones and AI, because you're often flying over something, you've got to find what it is you're supposed to be looking at, and once you've recognised that that might be what you're looking at, you then need to inspect it a little bit closer to find out exactly what it is. So this is something that we're doing on a number of different projects. Another one of these big problems a common problem that we're having with our drone projects is the challenge of class imbalance. So as we're building our machine learning model, you saw those disks. There's so many of those disks on every power pole. When we come to building our machine learning model, we might have, if we have way more of one object than we do of another object, that's going to skew our model. And so this is a significant problem that has to be overcome. This is a related problem, but another one of the really big issues is that faults are much less common than healthy examples. So when we're building our machine learning model, we're trying to get a whole lot of photos of healthy tops of poles and then photos of unhealthy tops of poles so we can tell the difference between them. But there's a lot less photos of unhealthy poles. So our machine learning model is likely to be less reliable. So how did eSmart Systems go around doing that, resolve that? Well, they mixed real and synthetic images. So they went through and they generated 3D models of, when I'm reusing the word models, 3D models of the power poles. What they were able to do then was actually inject faults, and they were able to model faults and then capture images of those faults, which is a great idea. So they actually did this a couple of years ago. If you're coming to do it today, you can actually cheat. So Microsoft's actually created Microsoft AirSim. And what AirSim is, it's built on the Unreal Engine. It's an open source project. If you go to the website, you can actually go and download it and download a tutorial. And what it's going to do is it's actually going to simulate flying around in the Unreal Engine in a drone. So what you do is you model the thing, you model the power pole, and then you can fly around it in your drone, capturing a whole lot of different images. What's really important as well, though, you can't have all of your images in your training data being in the middle of the day if you're going to be flying your drone in the morning and in the afternoon and maybe with a bit of snow around. So you can fly your drone around a healthy pole, stick a few cracks in it, fly it around again, make it morning, fly it around again, make it afternoon, fly it around again. You're able to simulate it using AirSim and build a much healthier machine learning model. Is that pretty cool? And that's what it looks like. So you can see there's depth perception, there's object perception, and it's fully, as an ex-Unreal player, I think that's, I'm glad to see the Unreal Engine still kicking along. The other really great thing that we're working on is Project Brainwave. So, when CPUs are designed to have a couple of threads and to execute things sequentially. The nice thing about graphics cards and why we use GPUs is they're meant to be highly parallelized. Project Brainwave, the idea of Project Brainwave is to take it to the next level. So what happens with Project Brainwave, what I've got here is a map of the whole United States. Oh. There we go. What I've got here is a map of the whole United States. And we've got a machine learning model that's doing, that's having a look at the land use for each of these different squares. And it's going to go through, and this is it's called land cover mapping, and we use it to identify what's going on. You can see if I click on CPU, it's operating. It'll process about 6 per second. GPU at about 60. Brainwave processes at around 500 images per second. So we can do the whole of the United States in about 10 minutes, and it'll cost about $80. So this is the opposite to the IoT edge scenario. This is, we've got something massive that needs to be executed. We can just hand it over to the cloud, run it in a massive parallel environment, and get the result back we want for not much money without massive hardware investment. Now, let's talk about drones. What's the easiest way to get started on drones? Luckily, Microsoft's come into a strategic partnership with DJI. So now DJI have released a Windows SDK so that you can, if you've got the right drone, interact with your drone using C#. Who's a C# developer? Yep. Things just got easier, kind of, and I'll explain why in a sec. So the Windows, so you can just go to the DJI website, go to the Windows SDK, and as long as you've got a Phantom or a Mavic Air, you're actually able to write C# code and WPF, and you're able to control your drone, get your video stream, either run an AI model on it locally or push your stream off to the cloud and do amazing things with your drone using C#. It's only in beta and they're still working on it, but it's great that there's that partnership there that's going to make it easier for us. I'll talk more about the scenarios where this makes sense in a minute. So it's great that Windows SDK is there. Just be careful, when we're talking about buying a drone, ping me before you go and buy a drone. There's lots of little subtleties around it. The Mavic Air only supports Wi-Fi. Which means you're using Wi-Fi to connect to the drone, which means you then can't connect to anything else to connect to the internet. So you can't do any of these scenarios on the Mavic Air. I think the Phantoms are being deprecated. So I think most of the new tech seems to be going into the Mavics. So if I was going along, I'd be looking at getting a Mavic these days. So in this talk, I'm only talking about DJI. And the reason for that is it's kind of the de facto standard now. They are so far ahead on everything. It would be really nice if they're kind of the Apple of, they're kind of the early Apple of the drone ecosystem. They're so far ahead, their capabilities are so advanced, it's just what everyone's using at the moment. But it'd be nice if someone caught up. So, if you're not going to build using the Windows SDK, what we have been building, what everyone has been doing, is using the mobile SDK, which literally means going along and either writing a native iOS app or a native Android app. The nice thing about that is you can do that with every single drone in the DJI catalogue, including their nice big drones, the Inspire series and the Matrix series. So what that means is you're building a custom app that's going to run on your tablet, that's plugged into your controller, that's talking to your drone. So you're able to get the feed, customize the UI, make it take off, land, steer, see your bounding boxes all over the top. All of that's very doable. Still, who'd rather write iOS or Android? Then there's the next two SDKs is where it gets really interesting. And this is where I'm doing more and more work, is when we go to the bigger drones. Those first two SDKs are really used a lot with the smaller drones, with the little Mavics, which is about this big, and the Phantoms, which is both of them are about a $3,000 drone. I'm doing a lot of work with the newer drones, which is fun. The newer drones are the M200 and the M600. The 600, I think, is about $7,000 to buy and has a $17,000 camera on it. It's not mine. But the amazing thing about these drones is they support 2 extra SDKs. There's an onboard SDK, which means this is where I can now take my machine learning model, stick it on a TX2, mount it on the drone, and now I've got real-time communications. So when we start talking about autonomous drones, and when we're talking about low latency, I want my drone to be flying along. I want it to recognize something. I don't want it to have the latency of communicating back to the ground or back to the cloud in order to make a decision. So what the onboard SDK does is let my TX2 make a decision based on the video feed and talk directly to the drone and control it. In most countries, this is still illegal. Autonomy is still one of those things that's coming, but when it does, this is going to be a much bigger deal. The other one is the payload SDK. On the latest version of their big commercial drones, you can actually swap out different cameras and different payloads, and that's customizable with the payload SDK. The catch with all of these things, is you're either writing native Linux APIs, you're using RTOS, which is the robot operating system, or you're writing embedded systems. And I've learned more new languages in the last 6 months than I have in the last 4 years. And I'm a guy who likes new stuff. So if you get into this, you are going to have to learn some new things. In general, this is how our drone architectures work. So you have the flight controller sending data through a gateway, and it's streaming up to IoT hub. And this is where this whole talk was around drones and IoT, because really, your drone is just another IoT device. Most of the code you're writing is just IoT code. We can take it to the next level in this scenario where we're using stream analytics to talk to a web app and we're doing some machine learning. I want to go back to this guy. As I've said, I'm a little bit ambitious. I bit off more than I could chew when I bought that surf ski, and I spend a fair bit of time in that creek. Now, we don't have saltwater crocodiles where I live, but we do have a lot of bull sharks. Lots of bull sharks. And so I spend a fair bit of time in there, and let me tell you, I'm not great at keeping it up, but I'm really good at getting back into it. And that's actually how I ended up here talking about drones, because there's a whole lot of controversy. So we've had a fair few shark attacks back at home, and there are some councils nearby where I live will put nets to keep the sharks away, and there's other ones that refuse to because there's a lot of bycatch. It kills dolphins and whales and turtles and fish, and there's lots of innocent animals get killed in these nets that arguably don't help stop people from getting eaten. So I think about sharks a lot because I'm in the water a lot. And so I was doing all this AI, I was doing all this IoT, and I thought, what I want to do is I want to build a machine learning model to detect sharks, and then I could go to Ballina Council, which is near where I work and where I paddle and has most of the attacks, and I could go to them and create a drone shark net. Wouldn't it be awesome? This is my idea. So if someone wants to build it, you just give me a little commission. Wouldn't it be great? And should be completely doable. I want drones to have this machine learning model that they can fly out over the ocean in like a semicircle over 100, a radius of 200 meters, and just look down. And if there's a shark, send up an alert. Isn't it the best idea? So I ran around for about three or 4 weeks saying, this is my idea, and I'm going to do a proof of concept, and it's going to be awesome. And then someone said to me, well, I've already done that. And they haven't actually done the SharkNet, but this is an iconic brand. Westpac's one of our Australian banks, and they have for 25 years been sponsoring helicopters that fly up and down the beaches in Australia saving people and looking for sharks. And what they've done, though, is they've partnered with a group called the Little Ripper Group. And what the Little Ripper Group have done is they've actually come and they've built this machine learning model that will actually detect sharks in the water. So it can see dolphins, it can see sharks, it can see surfers, and so they're able to fly drones. And this is one of the examples. So this is a customized Phantom. So they fly the Phantom out over the water, and it's actually it's then streaming the video back to someone sitting on the beach underneath a big shade. They've got a Alienware massive laptop with a couple of GPUs in it to run the processing, and then they've got a generator because the laptop's so big. So you're sitting on the beach with a massive computer and a generator in the heat. But these guys are cool. They're spotting sharks using drones, which is pretty awesome. So I've actually started working with them because we're going to make that better. We can do much better than that. So at the moment, we are taking that scenario of the Phantom. The Phantom's coming down. We're talking to a computer. What I'm working with them on at the moment is taking that scenario, and we're just streaming that data out to Azure, and then we're using Azure Media Services to push that through to a command center and also make people able to subscribe. I want to look at the beach and see if anyone spots a shark. Okay, so that's one scenario, and that's not bad. But and we're improving that by replacing this is 3 or 4 things down our backlog is replacing that computer there with a TX2 strapped onto the back of the controller. So we're moving away from this massive gaming laptop to a tiny little box with a whole lot more GPU cores in it. What's more fun is this. This is the workshop. So you can see there their first big drone is shaped like a helicopter, and that's a heavy lift drone that can lift 25 kilos in the background. They've moved away from these helicopter-style drones because they kill people. Even for helicopter pilots, they're really unstable. So this is what we use now. So this is a DJI M600. So this is pretty awesome. So this is where we're building the machine learning model, putting it on the TX2, and putting it on this bird so they can fly it around and have real-time detection of sharks. Pretty awesome. What's even cooler, this is just in the workshop, I took the photo. So this is obviously a promo shot. You can see on the back of it, they've built it so that it actually carries 2 life pods. So, and they actually saved people just before Christmas. 2 swimmers got stranded, got caught in a rip, swept out to the ocean. They flew the drone out, dropped these down, they inflate automatically when they hit the water, and they were right for 5 minutes until the surf lifesavers came and rescued them. So pretty cool. So what this scenario is going to look like is we're taking that same machine learning model, and this is where I'm going to have to apologise to my machine learning friends, because we're having to, I think I'm going back and working with the data scientist to make his machine learning model a little bit less pure, and actually a lot more than mine. So at the moment, it actually is an award-winning machine learning model. I'm trying to make it just a little bit less accurate so that I can run it a little bit faster and stick it on my drone. So we're going to be running that on the TX2 with that talking to that onboard SDK, streaming data back to the controller that then is going to push it up into the cloud. Who thinks that's cool? Yeah. The next one on the backlog, which is why we're getting to the other one later, is actually removing that communication from the controller so that the drone will be talking straight to the cloud. And now, once we get to this scenario, we can start doing coordination of drones. So now life gets really interesting. But this is where the drone world is. The drone world is still challenging. It is still very new. All of the automation around it is still illegal. The laws and the legalities around drones and AI is fascinating. What I love is that to be able to fly one of these drones, you have to have a commercial pilot's license. As soon as you have a commercial pilot's license, it's a commercial aircraft. If one of the pilots crashes the drone, they have to report it to our Civil Aviation Authority. And if someone comes along with one of those little toy things where you can steal people's drones and steal one that's flown by a commercial airline pilot, they've committed a federal crime because they've hijacked a commercial aircraft. So it's an interesting, fascinating place to be. I'm looking for people who are interested to come. If you're interested, come and have a chat because there's lots of interesting things going on. When it comes to drones, latency is a killer. Onboard is non-trivial. I've got scars from my TX2. I spent 2 days trying to just flash that board, and it turns out you can't flash it from another Linux machine running in a VM. It has to be bare metal, but it was documented nowhere. But the onboard is amazing. 2-stage detection in your AI is often the key. But you need to be comfortable being uncomfortable. You are all the time going, well, maybe the answer is this ROS operating system that I've never heard of, and I'm going to have to go and spend a few days investigating it because that might be the answer to the problem that I have today to solve this problem. So they're my key drone lessons. I hope you've enjoyed the talk. In general, what I've talked about is that Microsoft is deeply committed to AI and IoT. We are trying to make it easier for developers to do more. With drones and IoT, the cloud solution is the easy part. It's well documented, it's tried and tested, lots of people have done it before you. All of the challenges, though, come before the gateway. Particularly with drones, but with IoT, getting those devices, you need to have a device manufacturer who can help you get that and do it the right way. If you want to get into this, it's a fascinating field. There's lots of work. Start with the MxChip and the Raspberry Pi. Go to the Azure website. There is a couple of weeks' worth of fun tinkering around with the Raspberry Pi and the MxChip, building really cool solutions that are really well documented. Use Azure Sphere to the end-to-end security, and use the TX2 for powerful edge compute. The big deal is don't go and buy a drone and drop a whole lot of money thinking I'm going to code a drone, because you need to find the drone that matches your use case. I'm super happy to have a chat if you want to try and work that out as well. And with these emerging technologies, more than anything, success in emerging technologies requires a village. Don't try and do it yourself. I am poking people. I'm literally finding, oh, that's a great use case. It's written by this person. I'm going to ping them, whether they're at Microsoft or not, and see if they're interested to chat. Everyone in this space is learning and trying new things and has been really fantastic. So make sure you reach out. Look, thank you very much for coming and seeing my talk. I'll take questions out the back so that we can get ready for the next speaker. But muito obrigado.